Hello everyone, Oberon, back online again. Okay, in this episode I really changed my first intention to go further in a real giant leap, more to gadget programming. But as I told you in the last episode, I needed weeks to get all this stuff you need to know when you want to do real professional gadget programming into my brain. So I had really some second thoughts. If it would be a really good idea to do all the stuff in one video. So I stepped back from my first approach. And I decided to split all these topics into multiple video episodes so that I can give you the opportunity to follow the stuff more easily. Otherwise, I think we might run in the danger that you could be very frustrated and give up on programming Oberon, and I really don't want this. I want you to encourage to spend your time with Oberon and doing programming with Oberon, because I really believe this is a so well structured and useful and economic language that it shouldn't vanish in the dust of history. Okay, so I decided to make more videos, and first I thought it would be cool to have multiple little programming examples for every topic I wanted to explain, but I made my decision against that approach because in the end you have a lot of little programming examples that are absolutely worthless because you're running for a clear goal. That means you want to do a professional gadget programming. That means you want to have a gadget at the end that you really can do something with it, and not just telling hello world or changing the color of a circle from black to white or something like that. So I decided to build all my future videos for this topic around one example I'm going to show you at the start, and then I'm going to explain video by video all those tiny details, how you come to the point that you can do this programming of gadgets by yourself one day. Okay, and my first step would be to go step back a little bit, and to tell you something more about the theory of Oberon and the gadget programming, and about the question what means object-oriented programming in Oberon. What are the differences against the classic object-oriented programming you know from Java or from C++ maybe, and what's the structure of a module. And I think these are the very essential bases you have to know when you want to proceed, and we're going to start with this right now. Okay, let's start with the question, what does object-oriented programming means in Oberon? At first, we want to talk about what is classic object-oriented programming. So, in classic object-oriented programming, you have always a base class that is named object. An object is the basic class of something that has persistence, that you can put data on it and you can apply methods to it. When you want to make own objects, for example, you want to make an object that is named thing1. You get this object by deriving it from the base class or from maybe a higher class, but this is the very basic approach when you're making thing1 by deriving it from base class object. And when you have done this, you have the opportunity, for example, to add methods and to add properties. Okay. Properties is something where you can store data in, and methods is something that deals with data, that does something with it, that computes other things with it. Okay, and you can follow this path further. You can say, okay, I want to make another object, named thing2, and in thing2 you have let's give it a name here, methods1 and properties1. And when you derive the second object, you also have method1 and you have property1, and you can again apply additional methods, for example method2 or property2. Okay, that's the normal way that you know object programming is working. Now, when you want to call a method and do something with the data, the normal convention is that you apply the name of the object, let's say thing2, and then we have a dot notation, and after the dot we write the method, let's say method1, and then some data. So this is the way you do it, for example, in Java or in C++. And the method is always a part of the object. The object is comprised of properties and methods, and this is something that is followed straight ahead through all the paths of object-oriented programming, that you always get all the stuff you have in the object hierarchy, starting from object, is derived through all those other objects you are making. You always have the whole history of the object contained in your new class. Okay, now let's see how in Oberon it's a little more, let's say, economic. The approach is a little more economic. In Oberon you have also a base type named object. But object is nothing more than a data structure. For example, a structure like you do it with the command struct in C or C++. In Oberon it's named record. So this is nothing more than a data field containing different fields for integer and boolean and characters and stuff like that. So the object is made as a record, and it contains data. Okay, now what's a module? A module is something that also contains data. For example, if objects are declared inside the module, or basic data types like, for example, integer values. And additionally, it contains procedures. So this corresponds to the methods in object-oriented programming like Java or C++. Okay, if we take a further look, a closer look to a module, let's call it module 1, some module you are making. In this module you can declare a data type. For example, a type we name myType, and myType is derived from object, from this here. Okay? And then we have procedures. Procedure 1, procedure 2. This is all part of the module. Now, if we call this module a function, no, let's go a step back. Let's say we wanna instantiate this object. Let's call it object. And the structure of this object is contained in the module, namely in this declaration of my type. So if we want to do something with it, we want to instantiate it, we would apply the operator new. It's the same as in C or in Java. And we would give, for example, my type 1. My type 1 would be, for example, a declaration somewhere in our module where we write, don't have enough space here. For example, in the var section of the procedure, we would write my type 1 is of type my type. This will be a declaration. And when we apply this parameter to the new procedure named new, then the space in the memory is allocated to the variable my type 1. Okay, then from this moment on it is existing. And when we want to do a procedure call, then we would write module 1. So this is really the module, our base class here. It's not the instantiated object, it's the base class. And the dot notation, and for example, procedure 1, and as a parameter, my type 1. This one here. So I hope you can see the difference. In the classic object-oriented programming, the method is always part of the newly instantiated object. So this is not the method of the base class coming from here, for example. This is method 1 is coming from the object thing2. In Oberon it's different. In Oberon the base class, the module you once defined, stays all the same. You can see this as a static class that is not instantiated. What you do instantiate is just the data type named my type 1. And you take the data type and you apply it as a parameter to the base, or let's say static class, and the procedure you want to invoke. In this case this is module 1, procedure 1 and my type. So this is the difference that you need to know, the main difference between the classic object-oriented programming and the Oberon object-oriented programming. In Oberon you don't have methods derived from other objects in your module. You always have a base class and you're applying your data structure that you declared as a parameter to it. And this is where my first problems I had when I started object-oriented programming in Oberon, and that I did not understand this concept very, very good. And so I had some traps I fell into. Okay, I hope this is clear for now, because this will guide us through all the path of gadget programming we will do in the future videos. Okay, the last part of this video, this is the structure of an Oberon module. I want to tell you this in a very basic form, and I hope you can memorize it in the future, because this has always been done in the same way to make a clear, structured and professional programming. So, in Oberon, module always is made by file. In first class, Oberon module is a file that is stored on disk and has a name. And when you open your editor, like me, I made an example named modexample.mod. This is just an an example module for you to show how a module should look. At first, a module should always contain a header. A header is something that is written in comments that tells what this object is supposed to do, what its module is supposed to do. It should contain some hints how it is working, and you always should also contain who has written this module and what's the version. So you can distinguish the different, possibly distinguished versions on your system. Then there's a section with something I call tools. These are tools to compile and to test the module. For example, these compile commands, compile with this /s extension to generate an extended symbol file. Here I can invoke some functions I declared here in the module for testing purposes, and also very important is the system-free command to get rid of the old pre-compiled version when you made a new one. And also very important, I think, is a possibility to back up your files on floppy disk. This is done by the backup write files command. Okay. The next very important thing is that you have a module declaration initiated by the keyword module, always written in capitalized letters, and the name of the module should correspond to the name you gave it in the file. So it's mod example written here, it's also mod example written here, always terminated by a semicolon. Then you always have to import modules. Some modules you need on the system, for example, to write something to the log window, or to compute something, or dealing with attribute messages. And all the modules you need should be listed here after the import statement, also terminated with a semicolon. And then you have a type section. This is not always necessary. In type section, that's the same meaning as in C, for example, where you can declare your own data types. In Oberon, these are records, but here we don't have any records, but you can see we have here some kind of abbreviations. You can list, for example, a type that is defined in the module modules. It's named modules.module. Or modules.command. These are data types, and we give it another name. We just say module does mean modules.module, and command means modules.command. So you can use these abbreviated identifiers here in the source code, like if you would have applied the full name here. So this is something like an abbreviation. This is widely and frequently used in a lot of Oberon commands. Okay, and then you have the var section. The var section is for all the modules that are, let's say, global to the module scope. Anything that's declared here can be accessed in the whole module. Okay, and then you have the procedures. A procedure always should have a header telling what the procedure is supposed to do. For example, this procedure loads and executes another module that prints hello world to the screen. And the procedure itself is always initialized by the statement procedure, also written in capitalized letters, followed by the name. Then we have some very important issue you really must not forget. This is this asterisk. The asterisk here is something that makes a procedure or even a variable globally visible outside of the module. This is something, this is the same like as, for example, the public statement in Java. Everything that is public is visible also outside of the object. And this here is done by the asterisk sign. So every variable or every procedure that is followed by this asterisk sign is globally visible outside the module. If you forget this asterisk sign, this is just internally usable. Okay, the procedure, like you can see here, is something like a mirror of the module itself. It can also contain a var section. You can also apply a type section if you want. And the keyword begin starts with it's the identifier for the recode where that's part of the procedure. The procedure always is terminated with the end statement, and the end statement has to be followed, this is really committing, has to be followed by the name of the procedure. So just applying end here is not enough. You must apply end and the name of the procedure named dynex, or like here, print version. If you forget to do so, this is an error, and the compiler will complain. Okay, and last but not least, you always have a section in the module. This is also preceded by the begin statement, and this is a part of code that is always executed when the module is loaded. So the same like code that starting here in the procedure with the statement begin, we have the same here in the module. The module is loaded. This code is always once executed, only after loading. So you should do all this initialization stuff here in the section after the begin. So, and if the module ends, you also have to apply after the end statement the name of the module. This is the mod example here. And the difference between the procedure end and the module end is that the module end is terminated by a period, and the end statement of the procedure is always terminated by a semicolon. Okay, I will put this example also in my public Google file drive, so then you can use it as a blueprint for your own modules. Okay, let's check it if it works. I already compiled this stuff. Let's see what our lock screen says. I now will click on dynex, and you see, hello Margaret, this is the name of my wife. This is dynamically loading another module named hello and invoking the print procedure. And when I click on print version, you can see the version is printed, and every time I click again on print version, you can see that the parameter is incremented step by step. So this works. Okay, so I think that's enough for now, and next time I show you my homemade gadget. I think it's really cool stuff, and it's very interesting. It's a measuring application, something like a virtual oscilloscope where you can see data samples, and I will explain everything around gadget programming, what you need to know around this example. So thanks and for watching, and bye for now.